All right, so the answer is HN for that. Charge on halide skip, core electron skip. 30. Bonds in hydrocarbons are best categorized as non-polar covalent. That's A. 31. What is the predicted ideal bond angle in NH2 minus? What? 109? 109 is correct. 109, because around nitrogen, what do we have? How many lone pairs do we have in NH2 minus? 2 lone pairs and 2 bonded atoms. So it's tetrahedral, it should be 109. That's correct. NH2 minus is the amide. Highest ionization energy is helium. Yes, that's true, but it's not going to be on this test. The 33, what is the predicted bond angle in BF3? .120. 120 is correct. It's trivial planar, 120. Sometimes the best thing is to draw it out and show the structure. 34, resonance structures were on the last test. They won't be on this test. What is the shape of pH3? Trigonal pyramidal. That's correct. pH3 has 1 lone pair and 3 single bonds. 36. CCl4 is a polar molecule. It's false. CCl4 is tetrahedral. All the bond dipoles are canceled. How about CH2Cl2? Is that polar or non-polar? Is that polar molecule or non-polar? Why would it be non-polar?
Don't the dipoles cancel each other out?
Because they're equal and opposite? Yeah. Yeah. It looks like it could be non-polar because if I have a dipole pointing this way and a dipole pointing this way, then they're going to cancel each other out. Equal and opposite. So if there's a tug of war, seem to cancel. But what if I drew this molecule like this? Would they still cancel out? No. In fact, this is an optical illusion. They don't cancel each other out. It looks like they cancel each other out, but they don't. It's because we can't draw these on the opposite side. I mean, if you try to make it on the opposite side, let's draw this. What is the structure of this? Tetrahedral. So let's draw one chlorine here. And now I want to draw a chlorine on the opposite side. Well, is this the opposite side? Well, it's 109.5. Maybe, maybe not. Is this the opposite side? Well, it's 109.5. Maybe, maybe not. Is this the opposite side? There's no such thing as the opposite side. All the sides are next to each other. And so it doesn't matter which side we pick, it's going to result in the same thing. That is, the bond dipoles are not going to cancel. It's tetrahedral like this. And so if there's a bond dipole this way pulling this way and a bond dipole pulling this way, the net movement will be this. So some people think of this as like horses pulling on ropes. If you have a horse pulling this way, a horse pulling this way, the net movement's going to be this way. So CH2Cl2 is a polar molecule? True. No matter where you draw the chlorines, it's always going to result in polarity. '39, draw a 3D structure for CH4. I expect everybody to be able to draw this structure. What is that structure? CH4 has what shape? Tetrahedral. So, do you guys know how to draw a tetrahedral on paper? Okay, good. But what would the EG for be? MG? An angle? Yeah. That's it. So stoichiometry, limiting gradient problem, number 40. Number 41, draw a resonance chromosome minus. Detail the orbital energy level diagram. Okay, here. Not only do we have to be able to draw a tetrahedral, it's also a good idea to be able to draw more complex structures like this. Do you recognize this molecule here? NH2CH2COOH. Anybody remember the name of this molecule?
It's a carboxylic acid, right?
It's a carboxylic acid on the right side. The COOH is acid, carboxylic acid. On the left side is not. On the left side we call it a amine group. It's like ammonia, so it's amine. And so this is amine and an acid. Amine and an acid they call amino acids. This is an amino acid. Do you recall the name of this amino acid? What's the name? Starts with a G. Glycine. This is the amino acid glycine. We did this one in class, so hopefully this one's in your notes. You have a good drawing for this one. Well, as well as other ones we did. Not just glycine. But if you look back in your notes, you recall around nitrogen. What was the geometry around nitrogen? It was the EG around nitrogen. Yeah, EG was tetrahedral. The geometry, the MG. Did you say trigonal planar earlier? Or yeah, it's not trigonal planar, it's not bent. It's trigonal pyramidal around the nitrogen. So it was a tetrahedral EG, trigonal pyramidal MG. How about this carbon here? What was the EG on that carbon? Tetrahedral, and the MG? Tetrahedral. And so when we have tetrahedral EGs, that's going to set the angles. So the angles around nitrogen should be 109, and the angles around this carbon should be 109. But this carbon's different. What about this carbon? What was the EG and the MG around that other carbon there? Trigonal planar and trigonal planar was the EG and the MG around. And trigonal planar, that's going to have what angle? 120. And then this oxygen, the oxygen of the bridge is carbon with hydrogen. So it's carbon, oxygen, hydrogen. What was that oxygen? EG. Tetrahedral MG. Bent. Angle. 109. Okay. So that's the amino acid glycine. We looked at some gases. Part 2. 1. Calculate the volume of nitrogen in a 1.00 mole sample at 19 degrees C and 21.00 atmospheres. And so what we do is we just use the ideal gas equation to figure it out. volume is equal to nRT over peak. Now you should know the ideal gas law, PV equals nRT. But you don't need to memorize R. I'll just give you R. R is 0.08206 liters atmosphere per mole Kelvin. And so what do we need? We need N. Well, N is 1.00 moles. We need R. This is R here. We need T. The temperature has to be in Kelvin, not in degrees C. So 273 plus 19 would be 292. And we need P, which is 1 atmosphere. We've got to make sure the units cancel out. The units will cancel out. And that leaves us with, has somebody calculated this already? 0.0826.
Yeah, so that's how I got that in my notes from
All right. No, there's got to be a 0. There's two ways. In our book it's often written as 0.0821. But that's okay for 3 sig figs. In Chem 1A, you'll have to know it to 4 sig figs. And so rather than memorizing it once and then re-memorizing it for Chem 1A, it's just easier just to memorize it to 4 sig figs. Now, don't even bother memorizing this. But you don't have to memorize it because I'm just going to give it to you. In Chem 1A, I'd expect everybody to have it memorized. So what's the answer here? So 1 times 0.08206 times 292 divided by 1. 23.96. 23.96 would mean E. Correct answer. This E. 2, the molar volume of gas at 298 Kelvin and 1 atmosphere. A lot of people have this memorized. Why? Because 298 Kelvin is common. 298 Kelvin they call what? Common temperature. It's called standard temperature. Is 298 Kelvin standard temperature? No. Do you know what standard temperature is? Zero degrees Celsius. That is standard temperature. 0 degrees Celsius. 298 Kelvin is called room temperature. It's a little warm for room temperature, but that's called room temperature. And then 1 atmosphere is standard pressure. One of the standard pressures. The other standard pressure is 1 bar. And so since this is room temperature and standard pressure, a lot of people have it memorized. What is it? Do you have it memorized? 22.7 is not correct. No. Well, maybe calculate. Why don't you calculate?